way that I want to start this off is like how I ended up doing this presentation. And it wasn't because Glenn made me. It was because I use a tool, and it's called YNAB. Don't get excited. These are not my financials. This is a budgeting tool. I use it, and several other people here in the office also use it. The big idea is you set a budget, you have expenses, you can make transactions, and making a transaction literally just means adding a record. So I typed in Big Brother, it's for internet, it's the only internet provider, and the amount of money that came out is $80. The reason I'm showing this to you is because they recently came out with an API. Well, they actually came out with an API last year, but they didn't really announce it until a few months ago. And when they announced the API, well, I'm a software engineer. I got excited. I'm like, okay, cool. I can start scripting and whatnot. And then when I went to their API pages, they got me even more excited because they had a section called Best Practices. And that's something I typically don't see in API documentation. Maybe I haven't been reading enough. But they talk about caching, they talk about delta requests, fault tolerance, and specific requests. We're not going to review all of this. I'm mostly going to focus on caching, but I did notice while I was creating the presentation that I kind of ended up touching on some of these other subjects. So you're actually going to end up learning the majority of this kind of stuff. Okay. This is just to give you context. This is why I'm doing this. So this is the actual presentation. Okay. The agenda. What we're going to do is what is caching, why it's important, exploring the API, analyzing. This is probably the most important part. And the reason that's most important is because anybody can type code. It's the logic behind like why you made decisions, like why you're doing what you're doing, essentially. It's why people get hired. Then the next thing we're going to do after that is we're going to build a very simple cache using files and memory. And then we're going to make it nicer for the API. And then after that, I'm going to show you how to update your data when it gets old. Hopefully, we can cover all of this. I know it's a lot of stuff. OK, so first, what is caching? I defined it as this. We can talk about it. Caching is duplicating data from one location to another with the intent of distributing work and optimizing your product. You know, what is it? Change my mind? No. OK, so, but why should I have to cache? OK, so one of the reasons you should cache is because it's nice. The person that you're getting information from has limited resources, just as you do. The intent behind APIs is that the work is distributed amongst everybody, not just the person providing the information. You also want to avoid denial of service. If everybody's connected to an API and everybody's asking this remote server to do all of the work, you could essentially shut down their services, shut down your program, and then shut down everybody else that's using that same remote server. It helps speed up the product, and most APIs have limits at this point. In other words, you take advantage, they can ban you. What I wanted to highlight here was the fact that I defined caching as moving data from one location to another location. So I wanted to talk about what kind of storage you could use to store your data. I start at the very top with traditional databases. What I mean by traditional databases is MySQL, SQL, Postgres, stuff like that. And then you go down to SQLite, Redis, Memcache, file, and memory. The only reason I'm highlighting this is just to pretty much highlight the fact that you can store data anywhere. But what we're going to be focusing on today is file and memory. And the reason I want to focus on file and memory is because all of these other tools require you to learn another technology. And every operating system has these two things. I really want to focus on mostly looking at the API and making decisions and focus on the actual Python code. All right. Cool. Now, I did mention this to you guys, and I mentioned that I got excited about their best practices. And this is the other thing that I wanted to show you. One of the nice things that this API happened to give is a web interface for messing with their endpoints. So before you even start programming, before you open up a terminal, before you start making curl commands, what you can actually do is you can type in you can copy paste your token, which anybody who has an account automatically gets. So you're essentially a developer if you're a user, which is nice. And you can start playing with the data. So once again, this is not my real data. And then all you really do is you hit execute, which I've already done several times. And it shows you what the payload actually looks like. Here, I'll increase it just a little bit, or a lot of it. Oh, that was too much. Now, the reason I'm showing you this is because documentation is wonderful. But if you've been a software engineer for a while, you know that there's nothing better than the actual content, the actual data itself. It makes it much easier to program everything. OK. So some of the things, oh no, forgot my book. Some of the things that I want to highlight from their API is, their data types. And I'm calling them data types. We can call them something else. And what I mean by data types is the fact that they have budgets, they have accounts, they have categories, payees, payee locations, so on and so forth. You guys can read. And this is important because then you start to learn what kind of data is available to you and then the relationships between that data. And the reason I'm mentioning this to you is, once again, this is the process that I go through whenever I'm starting any kind of project. And this, in this case, specifically an API project. The other thing that I'm noticing is the actual endpoints themselves. The majority of them, you can retrieve an item. In this case, you can retrieve one account. Here, I'll scroll this to the top. Oops. Too far. You can retrieve one account, a single account, or you can retrieve a list of accounts. And it's the same for everything else, categories and payees. The other thing that I noticed was in the payloads themselves, accounts is plural here. I know that doesn't seem important, but when you're a bad speller, it is. And then when you retrieve one item, account, singular. And I'll highlight why that's more important in the future. But these are very nice tools. I highly recommend that when people start working with APIs that they start exploring before they actually start coding anything, because it's going to streamline your development significantly, I assure you that. OK. So let's go ahead and start building this cache. It's going to be super simple, I promise. The very first thing we're going to do is we're going to take, actually, let me give you my intent. My intent is if this is the payload, if that's the information that I'm trying to copy, to duplicate, to keep, where do I want to store it? I want to store it in a file that's named something like this. That's the easiest cache that I can possibly do. That means I hit an endpoint, I keep the name, I take the payload, I store it in the file. That's it. And that's what I'm doing for every single file. That's the simplest cache that I could build. So I do exactly that. I take the file path, I replace the forward slashes with dashes, and then I open up a file, .json, and then I simply write the file. That's it. I have now stored my payload inside of a file. Now I'm going to do it for the memory. In this case, memory, I'm just using a dictionary. That's all that I'm doing. And I'm doing the exact same process. I'm taking the URL name so that I have a key, and then I get the response, and I stuff it inside of that one key. So now we have cache inside of a file, and we have cache inside of a memory. Let's actually make a method out of it. And we've already gone through this. You guys saw me do this. I got a little fancier. I stripped it so that any white spaces on the side gets removed. I lowercased it to make it case insensitive, and then I did what you guys had seen before. I stuff it inside the memory, and then I save it to the file. Now, you guys could look at the to file and say, hey, that's a convenient method. But you guys actually just finished looking at it, and just in case, it looks like this. Your name and your dump, your data. And that's it. You've actually created something that caches information. Now, we haven't actually seen any request happening yet. But before I get to that, this is kind of an idea of what I want these. I'm not even in this mode, sorry. This is kind of what your file names are going to look like. These are not real UIDs. But this will just give you an idea. And then, of course, every time you open one of these files, you'll have a JSON payload that has a list of items. OK, reading from the cache. So we figured out how to write to the cache. Now we're going to read from it. All you do is you look for the key inside of the dictionary, and then you return the item if it exists. If you don't find it, then you return none. Fairly straightforward. If you don't find it in memory, you can look for it inside of the file. The only thing special that we're doing here is if we find it in the file, we give it to the memory, and then we return it. And the big idea there is we just want to be able to quickly access it. Oh, I had a from file in here. The way you read it from a file is you open up the file with your name. You read the data. If you don't get an error, if you get an error, you return none. If you don't get an error, then you use json.loads to actually take the JSON, turn it into a dictionary, and return it back. And this is the method. So we had a cache method. This is the get from cache method. And on this one, it's the exact same process. I mean, you can see how easy this is in regards to you make a key. You look for the key in the dictionary. If it exists, you return it. If it doesn't exist, this is the stuff that we've already gone through. You get it from the file, you populate your memory, and then you return the value. I mean, we're not even, I don't know how many minutes in here, but like, this is a very basic caching system, and you're already doing your product a lot of favors for both your product and for the API itself. Okay, so this is actually querying the endpoint that we've been talking about for some time now. So the very first thing we do whenever we try to get a URL, and you'll see at the very top, is we'll try the cache first. If we actually have a response, we'll get out, we'll exit, and we'll leave, and we return the response. If we don't have a response yet, then we'll actually query the endpoint. I'm using requests, very popular module in Python. If we do have a response, and it's a 200, then I just use the cache method that we had already created. And all I'm passing in is the URL, which then generates a name, and then the actual payload itself. If we do get an error, we were looking at our, and I forgot to mention this, we were looking at this API documentation. You don't have to read through all of this, by the way. You just want to skim it. Oh, I've gone too far. All I really wanted to show you guys was the fact that they highlight the fact that there is an error key, which gives you error information if you ever do have a problem. And because I know this, because you can clearly see it, I'm able to actually reference the error and then give myself better instructions if something does go wrong. Cool. So this caching system is okay. It does an okay job. It does much better than if I didn't have a caching system. So one of the things that I wanted to do, okay, so it's okay. So I'm going to highlight a flaw. The big problem with this caching system is if you go to this URL, you retrieve a list. And if you go to this URL, you retrieve one item. The problem is this one item probably exists in that list. But these two are unaware of each other. They have no idea that they exist. So if you had 100 accounts, that's an exaggeration, you would end up making 100 queries here simply because you were not aware that those items already existed in that cache upstairs. So what we're going to do is we're going to make our cache a little bit nicer. What I'd like to do is I'd like to have each type of data inside of one file. So instead of those crazy, goofy names with all the UUIDs inside of them, I just want budgets, accounts, payees, and transactions. These are just examples of the kinds of files that I want written out. So whenever I make a query to either the list portion of the API or just the one item, I want it to go into the exact same file. So, I mean, these are the things that I'm just scribbling down or thinking before I ever actually start coding. So the idea here is the key would be something as simple as the word transactions. And then the payload would be a big dictionary with every key being the ID for every transaction. And then if we were to retrieve an item with a UUID or an ID, I would want to do the exact same thing, but the only difference is instead of populating all of the transactions, I'd want to populate that specific key. So things that are worth noticing are, in this scenario, we have two keys. We have the word transactions, and then we have the ID. Those are the two keys that we need. The other thing worth noting is this becomes a dictionary specifically. The reason it becomes a dictionary is because if this was a list, you'd have to loop through that list in order to find whether or not an item exists inside of it. And one purpose of dictionaries is to be used as references. The fact that you can just look for a key and then it'll give you the content that's inside of it. Okay. And how am I going to detect what kind of query this is? Well, I'm going to use the ends of the name. This one has an actual name called transactions, and then this one has an ID. So they end differently. So if I know that it's a transaction, I know that this is a list of some sort. And I know if it's an ID, this is an item of some sort. Now, I don't know what kind of item it is by just looking at the ID, so I also need this value as well. So I need those two values, which are useful. If I took these two values, this is not so useful to me, but that's OK. This is just for the simplicity of the code. So let's build that method. All I'm doing now is I take the URL path, I take the last two items, I call it tail and almost tail. Couldn't think of a better name. And then I check if the tail is an ID. If it is an ID, then I know that this is a one-item query. I'm only going to get one item out of it. Now, the other thing that I noticed earlier when I was reviewing the API was I noticed that there were singular and plural names. Account, accounts, transaction, transactions. You could say, Eloy, why don't you just go ahead and append an S whenever this happens? I can't. There's a category. I could append an S, but no. So categories. OK, so it pluralizes. You get a cache key. You get your ID, which is the tail. And then you have your data. Now, the only thing I'm really doing here is I'm kind of going in a little bit deep on the data because this is kind of useless containers around it. And I really want the meat of the data. So this is if you just have an ID. Now, if you're getting a list, it's a little bit different. All you need is the tail. So the word, imagine the word transactions. That's your key. ID is none because we don't have one at all. And then you loop through the data and you create a dictionary where you populate the key. That's the ID of the transaction, and then the actual content of that dictionary of that item is the payload. It's the actual content, and then I return everything back. Now you have a cache key, a cache ID, and then the data. So key 1, key 2, and the data. And once again, remember that key 2 could be none. It could be nothing. And now we update our cache method. OK, we update our cache method. So the very first thing that we check is if key 2 is none. All that's saying is if there is no ID. So if there is no ID, that means that this is multiple items. This is multiple items. I know this is a dictionary. I use the update method. I pass the data. I've updated my memory. Congratulations. I'm going to go ahead and skip else for now and go all the way down to toFile. This is the exact same cache method we had before, by the way, guys. All I'm doing is I'm putting an if-else statement in it. That's all that I'm doing. The key I already have. That's called transactions. And then the data is just the data that we just retrieved, that entire list that we just retrieved. And we're populating the list now. So now we have a transactions.json file because of it. Let me go back to the else statement. The else statement's a little more complicated. All you're doing here is instead of just doing key 1 and an update, you're doing transactions, the ID number, and then you're updating that one item inside of the memory. You're not updating the entire thing. And then for the file, what you're doing here is you're actually grabbing your old data, so that big dictionary that you already have, you're updating it with new data, and then you're just resetting the name to data just for simplicity's sake. And then the exact file gets written the exact same way. It's, once again, the word transactions. This is just an example. And then this huge dictionary that you're populating with all of your transactions or all of your accounts. I know it's a lot. And I'll definitely answer questions if there are any. So this is the new get method. This is the one that simplifies everything ideally. The get from cache doesn't really change. The only thing that really changes here is the way that we create our name. Instead of coming up with that jarbled up name, I made a get key method, which is exactly the same as this guy, but it doesn't bother with trying to figure out the data or the cache UUID. It's just trying to figure out this. That's all that it's doing. It's trying to figure out where that name is and whether or not it needs to pluralize it. You look for your cache. If you have something, get out. That's good. You don't have to bother the API. If you don't, you make your regular query that you did before. If it's a 200, you use that method that we just created, the get keys and data, which gives you 2 keys and a data, and then you just pass it into the cache. And that's it. And you've now retrieved data and you've cached it into a nice file format. I know it's a lot. Okay. Actually, let me show you. Oh, no, that's fine. Okay, let me show you. Okay, that's fine. This, keeping up with your data. So what we've accomplished so far is we've been able, every time we hit that query, every time we hit an endpoint, we make caches at a file level and we make caches at a memory level, which is wonderful. Every time we try to make another GET request, we retrieve the memory or the file. We've got all that stuff. How do you keep that up to date? In other words, if I were to make 20 transactions tomorrow, how do I know that there are 20 transactions waiting for me on the other end? The way that you do that specifically with their API, and I can mention other APIs as well, is they have this thing called server knowledge. In this case, it's represented by the number 0. And whenever you hit this specific endpoint, budgets, budget ID, what it will do is if there is an update waiting for you, it will show you only the updates that have happened and then update the server knowledge number. So if the number were to get updated to, say, the number 60, it'll say 60 and it'll say you have 2 new accounts. What you're able to do at that point is you're able to get that information, loop through it, update your information, and then the next time you send another query, you make sure that you send that same number right back to them. In other words, it's a way of keeping up with the difference between what you have and what they have. So you'll never have to query them for all the data again. This was very nice of them to do. Most systems require you to pass in the last ID number that you have, and then they would send you everything past that ID number. So this was very generous of them. Once again, this is just an example of what they might send you. Server knowledge 101, and they just happen to mention that here's a brand new account. That's not really the name of the account. That's just to highlight the fact that, hey, a checking account was renamed. Oh. OK, and that's it. I can answer questions. I know that was a lot. I kind of rushed through it. But I actually have code, and I can show that to you. And you don't have to read all of it now, but I mostly just want to show it to you just so if you guys are interested in looking at it. This is an actual Python YNAB client. The reason I ended up building the client was because I looked at their existing clients, and they were just too complicated. They were too complicated for me. They were ugly. I don't know how else to explain that. The APIs were ugly. So the big idea here is you have a client, you pass your token, and then you literally run commands like get transactions, and it'll do everything for you. Sweet. Yes, sir.
So the server knowledge?
Yes.
Is that like a global transaction ID, so that way?
Yes.
Like it's a number that always goes up.
Yes. So I was showing all these different data types. So you have budgets, you have accounts, you have everything, payees. That server knowledge number, anytime anything changes whatsoever, that number increases. And then it sends you everything. It sends you everything that's changed. It doesn't matter what the data type was, not just transactions, but anything on the system whatsoever, which I think that's a beautiful system. I think it makes a whole lot of sense.
So if you got a server knowledge of 5, and they say that, and you send it some kind of request with 5.
So I would send it, hey, would you send me budgets with server knowledge 5? They'll say, OK, we have 2 new transactions. Your new server knowledge number is whatever, 7. I'm really not sure how the number increments, but the number does increment. But yeah, and that's the idea. Now, if I send them back another query with that server knowledge of 7 and they send me back nothing, that means nothing's changed whatsoever.
But is that on like a per resource?
No, it's not on a per resource. It's everything. Every single resource that they have available. They're monitoring every single thing for you. Right. So you don't have to worry about.
So if I get one new transaction, but there's a new thing in accounts, the server knowledge is going to go up.
Yep, exactly. Yep. Yes?
I'm always a little bit weary about saving like files on the server.
Okay.
Because if I keep rewriting, I have this illogical fear that if I keep rewriting over it, it becomes corrupt. Is that founded or?
Oh, okay. I mean, could you do that? Yes. One of the nice thing, I guess, so first of all, this is all with my personal, not my personal data, but this is all this is not using OAuth. This is not a bunch of people connecting and using their financials. This is me just playing around with just a couple of financials. So the beauty of this is that I can actually go, let me see if I can pull it up real fast.
Are you referring to like corruption with the hard drive?
Just,
Yeah, so I think the
go ahead.
you shouldn't have any fear of writing to a file over and over and over again.
So I won't,
Bit loss happens in over TCP transfer, and that's over time. But I mean, if there's that fear, maybe your hard drive's going out. But I don't think you should have that.
No, I just maybe at my level, I don't feel like it's good practice to save on the server, but yeah.
But the server's got the same technology limitations that you do.
Yeah.
So spinning disk.
it's just another computer.
Yeah.
Whenever you hear like the cloud or the server, it's just someone else's computer.
I just feel like it's not, efficient,
It is.
Yeah.
That's what databases do. They like to do.
Okay, one thing on that though, so I've built something similar to this, and one thing you do run into, there's a caveat that you put that was really important, that this is for small amounts of data.
Oh yeah.
If you have large amounts of data and it takes a non-negligible amount of time to write that JSON to disk, I've had circumstances where something has interrupted the process and that file gets halfway written, and the next time it runs, it's not going to decode out that JSON. So it's not as though the file is corrupted, but it's going to break your kernel.
Yep.
That shouldn't happen.
Yeah, it's not a file system problem. But
It's a partial.
it's
It's a partial input problem, is what it is.
That is a incomplete response.
Right. You got half a message.
Covered in your caching.
Yep.
Well, but I think the scenario you're describing is like if I'm writing the new version of the file
Right.
over the old file with the same name, and you pull the plug while the write's halfway through, and I've got a halfway written file. The solution to that is you write the new file to a temporary name, and then you atomically move the temporary name on top of the old name.
Yes.
Right.
Yes. Yeah. There are a lot of. How do I say this? Right now, my goal here was kind of just to walk you through the process that someone might go through in order to create an actual caching system. And I wanted to keep the caching system as rudimentary as possible. There's a lot of things this caching system doesn't do. One of the things is it doesn't worry too much about file corruption. That's a big deal. Another thing that it does is this caching system can grow infinitely. Once again, it's a personal project, so infinite's not that big. I'll never have that much data. Yeah, famous last words. These are just some examples of actual files that I wrote out, and these are the ugly IDs, and then this is eventually the file names that got created later in the future. The other thing that I wanted to highlight was because it's such a small amount of data. If you're worried about corruption, you literally just go in there, delete the caches, and you're good again. And then it just retrieves the information for you once more. Yes.
I'm curious about why you only handled the 200 case, and if you did get an error, could you like clobber your caches, and now you got these error messages that you updated your good data with and stuff? Like, why didn't you just like raise an error and just like give up at that point?
I think it. Oh wait, did I hide an error? Is that what happened? I think I did. You're right.
Like a 503.
Yeah. Let's see. I just logged. Yeah. Don't do that. But no, he highlighted something very important, extremely important. As a developer, one of the things that you want to focus on is I don't know if you guys can see that from back there. I know some of you are further back. Actually, here, let me do this. I'll just find something. So here's a perfect scenario. Okay, so what's happening here is I'm explicitly saying I need a 200 and then I'll take the data. If I don't get a 200, I'm not even caching. No, that's a bad example. But the big idea is, let me see if I can find a better one. I'm sorry. Yeah. Yeah. Yeah, I'm not caching the response. But I guess really what I really wanted to highlight was the fact that, and this is something that I learned later in life, is in the beginning, I really wanted to kind of hide errors, which is kind of a weird thing to want to do. I wanted to just log it, take care of it later, keep my program running. I didn't want my program to blow up. But something that I've kind of learned later on in life is that there are situations where you explicitly want things to blow up. Like, that's on purpose. Like, if something is wrong here, I need to know now. And in this case, it's not really that important, but it is something to think about the next time you try to catch an exception and you try to hide it from yourself. That's it. That's pretty much just worth mentioning. Yeah. Okay. I hope some of you got this stuff, and if you didn't, I hope some of you got some of this stuff. Overall, I hope you guys liked the presentation. If you did, thank you so much. And if you didn't, you can catch me outside. All right. Thank you, guys.